Hello again. Picking up from where we left last time, I've promised you I will come back with IPVLAN. So this is what we are going to do today. Let's get to the drawing board. Where is it? Here. So one thing I think I have missed telling you about macvlan is that macvlan interfaces have unique MAC addresses. So let's draw this. Let's say this is our macvlan construct. And if I have here an interface and the second one here, let's say the MAC address for this one is A, the MAC address for this one is B, and I don't know, let's add a third interface. I can have the C address here, and I don't care about the MAC address of ETH0 actually, because I'm not communicating with the default namespace through ETH0. From a logical perspective, I am communicating with also with a macvlan interface like this one here, which has a distinct MAC address. So macvlan distinct MAC addresses. What about IPVLAN now? The topic of today. Again, we start with ETH0, and this time we have a IPVLAN construct. Let's say this is actually no. I represented it like this because I will show you both IPVLAN modes. First is layer 2 IPVLAN mode, which is behaving somehow or very similar with macvlan, with the exception that the IPVLAN interfaces do not have distinct MAC addresses. There is a MAC address here on ETH0, let's say is the MAC address A, which is shared, with all the sub interfaces. So frames from these interfaces, when are exiting on the physical network through ETH0, are exiting with the MAC address A. And if I have same as the first example, if I have another interface here in the default namespace, again, if I'm communicating with the default namespace, my frames will have the MAC address of the parent interface, which in my case is ETH0. And last, IPVLAN mode, layer 3. Again, we start with ETH0. And now I have like a router here. And again, I have the three interfaces, two in distinct namespaces and the other in the default namespace. Let's say here is layer 3. I don't care here about the MAC addresses. The distinction is made based on IP address. So here I have IP A, here I have IP B, and here IP C. I still need an IPVLAN interface in the default namespace in order to be able to communicate with that default namespace. And the way this works, I in my head, I picture something similar with a proxy ARP. Yes, something similar with proxy ARP, because the IPVLAN construct knows about all the connected IP addresses, and if I am sending, let's say I'm sending a packet here for, let's say, destination IPA, my IPVLAN construct will know which of these interfaces has the IP configured, and will know how to forward the packet to that interface based on the destination IP address, and it will accept the packet. So even mm, even if it's a bit, I'm thinking for a moment how to explain it to you in order to understand it better. Let me create a new page and draw again this thing and put some real IP addresses. For some network engineers, the IPVLAN, it's a bit mind-bending, and the way it works, because they are used with the traditional routing, let's say. So I have here one interface which has 192.168.100.10/24, and here I have another one from a different network subnet, 192.168.100. Sorry, that 200.10/24. As long as the route in this namespace let's say this is namespace 2. As long as my route, let's say default route, points to IP interface, this one here, like the default network is a directly connected network, the IPVLAN construct will know how to, it will accept the packet and will know how to forward it. So usually the default network, the default route is all that it needs to be created in the routing table of a namespace like this. By default, when you are creating a namespace and you bring an IPVLAN interface into it, it will have a directly connected route for the IP network of the interface. So by default, it will have a directly connected network, 192.168.100.0/24. But you can change that with a default route or whatever route you put in there. You don't need a gateway. That's the idea actually here, because normally you would need a gateway, but like in traditional routing. But in here, as long as you put the packets on the wire, they are reaching the IPVLAN construct, and the IPVLAN will know how to forward the packet. That's the whole and the most important idea about IPVLAN. So Again, if you have a default another interface in the default namespace, I don't know, 172.10.0.1/24, as long as I have, let's say I have a specific route, like for 192.168.100.0/24 through IP interface, I don't know, 0 or whatever it is, my packets will reach here, this network. Usually what I'm doing if I need to mess with the routes at the network namespace level, I just put a default route through the IP interface, and that's all that it needs to be done. Sorry. And that's it. And a very important thing about layer 3 IPVLAN, no broadcast and no multicasts are forwarded. So IPVLAN it's a bit more efficient on one side because it's not forwarding and these broadcasts and they're not consuming resources. On the other side, you cannot have routing protocols connected to IPVLAN interfaces because they will not work. Most of routing protocols are communicating through broadcasts or multicast. So no dynamic routing. Would be another thing. Other than that, it's maybe the most optimal virtual network connectivity from macvlan and IPVLAN with the two modes, layer 2 and layer 3. So I will demonstrate for you only the IPVLAN layer 3. I don't want to make this very long. So let's get to it. Sorry. Again, I will create two IPVLAN interfaces. Let me display the addresses first. So I will use EMP0S8. I will name my interface IPF1, type IPVLAN, and same as with macvlan, I need to specify a mode layer 4. Oops, I cannot have layer 4, and IP is kind enough to let me know I can have this. The argument mode must be one of these choices. So I will go with L3. Oops, again. Another thing that I haven't told you is that IPVLAN needs specific, not specific, it needs a higher kernel version that 4.2, I think. I'm not sure actually. Anyway, I have this version. So I actually have another kernel for this system, but I haven't booted into it. So I will reboot and see you with the actual correct version. I will pause the video right now. So back again with let's see what kernel version I have now. So Right now it should be supported, the IPVLAN mode. I will just go in root. Mode L3. I will add another one. Let's check our progress. Actually, let's go with details. I will only display the IPVLAN interfaces. So here they are in mode layer 3. So now let's create two namespaces for these interfaces. And put the interfaces into this network namespaces. Sorry. Let's start with the first network namespace and configure the interface there. IP network namespace. Link. I'm bringing it up, the interface. Let's go with 200. Let's say 200. That one. I will assign distinct IP address classes on each of the IPVLAN interface. So here it is. Let's go to the other network namespace. Exec. In here I will go with the next /24 class. So here it is. Now let's try and ping one namespace from the other. It is unreachable. Oops. Let's see why it is unreachable. Let's display the routing table from this namespace. IP route shop. So I only have as a directly connected network the network that is configured on the IPVLAN interface, right? So what I can do now is add another route here. IP namespace 1, IP route at. So the network from the other network namespace. Again, through dev, directly through dev IP if1. So if I'm pinging now, oops, not working again, because I don't have the returning route in the other namespace. it's the same stuff. So I will add the route. This time I'm adding a default route, as I told you. I can add a default route if I want. All right, so let's check again the first command. So right now, as you can see, it's working like a charm. So let's create also the IPVLAN interface in the default namespace. S8 name 0. Now I will bring it up. And assign an IP address. The next /24. Let's see it. So here it is. And again, now if I'm displaying the routing table here in the default namespace, I only have this one. Now, being in the default namespace, I cannot add a default route to like the one I did previously, because it will mess my routing table in the default namespace, and maybe actually for sure I have other networks that I need to reach. So I will add a route like this. 200. I can add for both /24 networks. 24 dev IP if 0. So if I'm adding routes straight through the device from the default network namespace, it should work fine. Actually, it should work only with the network namespace, the secondary network namespace, because that one has a default route. The first network namespace doesn't. See, but if I'm pinging this, it's pinging all right. That's because exec IPNS1 IP route. This has a specific route. It doesn't have a default. So if I'm putting here a default route, what? Oh, why is not letting me do this? Sorry, I need to specify dev in here. So that's why. Anyways, so now let's try again the ping. 201.1. So it's working again. What else do I need to show you? One thing that I haven't specified or shown you here about the distinct IP addresses. Of course, these IPVLAN interfaces need to have distinct IP addresses. I cannot have the same IP address residing in more than one place in the same time. So let's put it here. Distinct IP. Other than that, and this is just an assumption of mine, I think IPVLAN doesn't care about the whole network class in here. It cares only as much as creating that route to the directly connected network. But with regards to routing, I think it only knows the slash 32 address assigned to the interface. Again, it's just an assumption, and anyway, it's not a very, or I cannot think of an use case where I will have in a container another network. Let's say I just want need the I just need the one network connected to the container with just one IP address. So I don't know if I have missed anything about this IPVLAN. Um, Maybe the routing. I can show you also that the routing to the physical network in here, but that's easy and logical to do. You just configure more. I mean, basically, you configure the routing at the sorry at the in the default namespace. So that's pretty much the whole thing. Anyway, I hope this has been helpful for you and you are understanding better now the IPVLAN network type. I'm planning to do another hands-on session with IPVLAN and macvlan in Docker. So until then, thank you for watching. Bye bye.